Welcome to today's webinar, Stopping the Intrinsic Threat, Fileless Malware Blocking Made Possible. Today's webinar is presented by Lital Asher Dotan and Jessica Stanford, both at Cybereason. My name is Holger Schulze, and I'll be your moderator today. I am the founder and CEO of Cybersecurity Insiders, an online cybersecurity community that started with the 400,000 member information security community on LinkedIn over 10 years ago. For today's webinar, I would like to welcome Lital Asher Dotan, Senior Director of Marketing at Cybereason, and Jessica Stanford, Director of Product Marketing at Cybereason. And today, Lital and Jessica will discuss the threat posed by fileless malware and new approaches for stopping these attacks. Welcome, Lital. Welcome, Jessica. Thank you for presenting today. The floor is yours.
Thank you. I'll go ahead and get started. So for our agenda today, what we're going to cover, we're going to first set the baseline, what is fileless malware, since that's exactly what we'll be talking about for the next about 30 minutes. We'll also talk about why it's such a security threat in today's organizations. Then we have a really cool real-life example of a PowerShell-based attack. And then we'll wrap up by talking about how you can add prevention, which is a very unique new capability that just is hitting the market now, as well as how to detect and respond to these types of attacks. And in part of that, we'll show a demo of our product and how you can see how we do that within the Cybereason console. So before we get started, let's do that level setting with what fileless malware really is. And when it comes down to it, what it truly is malicious code that exists only in memory. So it never gets written to a disk as a file or any type of executable in that sense of a file. So in order to execute, fileless malware or fileless attacks exploit vulnerable applications or they use legitimate tools like PowerShell, which we're going to talk about a lot today, and WMI in order to propagate. And so ultimately these are really a top concern of organizations. I was actually just talking to a handful of organizations last week where they said their top concern are fileless malware attacks because attackers are able to operate undetected when they use these types of attacks. It's a lot easier to bypass existing security controls like an antivirus in order to propagate and continue their attack. And so in fact, what we've seen is that at least a third of successful attacks out there in the wild are using fileless malware at some point in the attack life cycle. And what we're seeing is that actually most of those attacks are PowerShell based. Even though there's multiple different ways, like I said, there's WMI, there's a handful of other techniques. The most common that we're seeing is PowerShell, and that's probably because PowerShell is so prevalent. IT admins legitimately use PowerShell all of the time. They're writing scripts using PowerShell to automate routine maintenance and monitoring, but unfortunately, attackers are also leveraging PowerShell. So let's talk about how they're doing that and why they're so bad.
So as Jess just said, PowerShell and in general the techniques that are leveraging fileless malware are installed by default almost on all Windows machines. So basically as of Windows 7, Windows have embedded PowerShell capabilities that are by default operational on all Windows machines, making it that easy to do lateral movement, to exploit several machines at a time, and that makes it easy for the attacker and really bad for the defender. The beauty of PowerShell in the eyes of the attacker is that it can execute payloads directly from memory, making it extremely stealthy, and a lot of the security tools that are based on kernel mode will not see those executable. It generates very few traces by default. It was built as an admin tool, so it makes it difficult to find them under forensic analysis. PowerShell as an admin tool has a built-in remote access capability, making it a rat that is built into your system, and it's even encrypted, so you will not be able to see the traffic. As a script, it is easy to use all kinds of obfuscation techniques. Very difficult to detect it with traditional security tools, well, very easy to hide it. It can bypass application whitelisting tool depending on the configuration of the tools and of PowerShell. And we know that because of its script-based, many of the gateway sandboxes do not handle it very well. They don't see it as a normal malware. They see it as just a native script to the system, and therefore they will just let it go normally. On the other side, there is a huge community that has ready off-the-shelf script for people to download from GitHub and different other places. Just take them, combine the scripts together, and run a full malicious operation without the need to even know how to script in PowerShell. It's as trusted by sysadmins that many of them will not even look at PowerShell activities as something that is abnormal or something that is malicious. So it's so hard for us in security to look at the logs of PowerShell activity and say what is legit versus what is a malicious use of PowerShell. And because of that, at the end of the day, defenders tend to overlook it when they go and harden the systems. Pen testers not always look at PowerShell. We have seen a very positive growing trend of red teams trying now PowerShell tools to point for security teams that they need to harden their capabilities on this area. And part of the reason that we are running this webinar is to build this awareness of how much this is widespread. As we said, this is becoming so common that there are just off-shelf PowerShell attack tools that anyone could use. Most of them are for post-exploitation, from PowerShell Empire, that is notorious, PowerSploit, PS attack, even Metasploit have PowerShell models now. So every red team or every attacker could now use them, as we said, very common. So it's not surprising that 1/3 of the attack, and probably growing, use those kind of tools. In addition, there are many other modules that attackers can use for obfuscating the scripts. There are social engineering frameworks that now have PowerShell add-ons. And we've recently seen some PowerShell without PowerShell capabilities that are kind of the cool thing, cool new things that you can do, running those kind of scripts without really running it. I want to mention an attack story that if you're interested to learn more about it, you can go to a website and search for a blog called Cobalt Kitty. It is a story of a long-term APT that we discovered on one of the organizations that we protect. It started with a year-long of Fileless malware that once we started being deployed on the customer's environment, we have seen. So a little bit about the information or the details of this. So basically what we've seen is that for almost a year, this organization had been compromised by a very stealthy Fileless operation. All of it was in memory, no single malware or external software that was used for that. So there were scripts that were running each time the infected machines were turned on. The script was launching PowerShell script with a simple task, fetch the real payload. payloads reside in memory and were never written to disk. They were leaving very little forensics evidence because of that. They were communicating with the C2 servers, and they were using the malicious payload to send critical information out of this organization. In the specific case here, we know that they were looking for specific emails from a specific department in this organizations. After we did all the IR work, we discovered that, and you're more than welcome to read about it. Here is a screenshot of how it looked like when we deployed the Cyber Reason solution, and Jess will show a demo in a few minutes from now about how it looks in real time. But basically, all you see is there is a PowerShell script that is malicious, and we'll tell you how we see this as malicious, that is running on some user machines, and by looking that, we were able to piece the whole story that was going on.
Great. Thanks, Lital. Yeah, so I'll jump to the demo in just a second, but ultimately what you need in order to protect against these types of attacks, these PowerShell attacks, these fileless malware attacks, is deep visibility into what's happening within your ecosystem. The only way that you can get that visibility is with some type of tool that's collecting information in memory. So you can't just rely on an AV to block these things, because exactly like we've been talking about, there's no file to even have an AV scan and review before it executes. And like we said, you know, it's a legitimate tool, right? So it's being used every single day. So the true trick is to tell the difference between the legitimate use of PowerShell and the malicious use of PowerShell. And that's really where having a behavioral analytics tool that can decipher that in an automated way is really critical when you're talking about protecting against these attacks. So a couple of things that you can look at once you have that visibility to tell those differences between good and bad use of PowerShell. One example is where PowerShell is running from. So we were just looking at the screenshot of the parent process. So for example, if PowerShell has a parent process of Microsoft Office, that's a great example of a malicious use. That's definitely not normal. You don't want to be seeing PowerShell running from a Microsoft Office parent process. Another thing to monitor are the network connections. So like we were saying in the example with that Lital walked through, it was making malicious connections to the C2 servers. So if you're seeing PowerShell make these connections out to a C2, a known malicious server, that's another malicious indicator that this is not a normal use of PowerShell. This is now a malicious use case for PowerShell. The last thing, for just a quick example before we dive into the demo, is to look for encoded commands. So it's really normal for an IT admin to not use encoded commands. They don't really have a need to use encoded commands within PowerShell, but attackers often will, because it's another way for them to avoid AAV and prevention tools. So if you're seeing a ton of encoded commands within a PowerShell process, it's a pretty good indicator to you that we're talking about an illegitimate use case for PowerShell. So just a couple examples there. So before I jump into the demo too, just a couple different ways to mitigate the risk of these PowerShell attacks. So one, you can upgrade to PowerShell 5, the latest and greatest version of PowerShell. It has introduced a number of security improvements over the previous versions of PowerShell. So there's things like transcript logging, script block logging, there's an improved constrained language mode. So if you upgrade to PowerShell 5, you can get some of those enhanced security features, which are great. One trick is that a lot of these features are not enabled by default, so keep that in mind. If you want to get these security features, you have to enable them. So I indicated that with its own bullet, because it's very important. In addition to keeping in mind, when we're talking about PowerShell 5 If an attacker has the ability to downgrade to PowerShell 2, which is still the most widely used version, it's running in nearly half of the world's machines out there, according to a survey that I was reading. So if the attacker is able to downgrade from 5 down to 2, it completely negates all of these security features, and that's something that we're seeing commonly used in the handful of attacks that have been against PowerShell 5. Just as a standard protocol, maintaining software updates is always a good idea when it comes to maintaining and mitigating risk. AMSI, so Anti-Malware Scan Interface. This is a really cool feature in Windows 10 because it really gets the closest to being a proactive control. So what it does is it gives AV vendors the ability to scan and block input before it's run by the scripting engine. So therefore, in-memory scripts are also being analyzed with this. But unfortunately, this approach isn't perfect as a standalone as well. So the most common PowerShell version 2 is not supported with AMSI, so keep that in mind. Several AMSI bypass techniques have been published and integrated into frameworks like Empire, so keep that in mind as well. And it's really only as good as the detection rules that AV vendors create for it, because they have to integrate with the AV vendor organization in order to have this be really useful for you. And then lastly, popular obfuscation techniques, such as token obfuscation, do not create new script block, and therefore they're not de-obfuscated by AMSI. So just a couple of things to keep in mind. While it's a really cool tool and something to look into, there are a few reasons why it's not perfect as a standalone. And then lastly, an option, though likely not a popular one in your organization, would be to just disable PowerShell, right? You can entirely avoid these attacks if you don't permit it whatsoever in the organization. You know what they say about abstinence. So while that's probably not something you would likely do, I had to list it as an option. Great. Okay, so here's a screenshot of the Cybereason console. I'm just going to pivot right over to our demo environment here. So what you're looking at is the Cybereason dashboard. For those of you that aren't familiar with our solution today, this is the discovery board. So this is the high-level view of what's happening within the organization. Across the top here in the black background, you're seeing MalOps. So what we say a MalOp is, these are our types of alerts or incidents. The way we define those is by all of the information that we're collecting into our engine. We're conducting behavioral analytics on all of that information that we're collecting from across the entire organization. And we deem elements of that data to be evidence, meaning that it's some type of fact that looks abnormal from a behavior perspective for some reason. If it's just a piece of evidence, we don't necessarily create a MalOp until we know with high certainty that it's something truly malicious happening in your organization. So what a MalOp is, it's multiple different pieces of that evidence and suspicious activity that's happening within your organization, and that's when we will alert your organization that something malicious is happening. And what you're seeing here is that we do detect malicious behavior across every single stage of the attack lifecycle. So not only do we offer antivirus, anti-malware solutions, preventing things from getting into your organization, but we also offer detection across the entire lifecycle of an attack. Everything from the infection to command and control connections, lateral movement, privilege escalation, all the way to data theft. So what I'm going to do is just jump into our MalOp inbox. So here you can see it's very similar to an email inbox. And what we're looking at are all of the MalOps that have occurred in this organization or in our demo environment here. So since we're talking about PowerShell, I'm just going to jump right into our PowerShell example here. And what we're seeing here is that what we call this is 5 pillars of the attack. So we're seeing all of the information related to this attack all in this one screen. So everything you need to know as a security analyst is right here for you. So we can see obviously the root cause here is PowerShell. It's fileless malware. It's actually affected 4 different machines and 2 users. So we'll get into that in a second. We can see that the malicious process, there's 9 suspicious processes happening here. And we can also see the connections that were happening. So in this case, there are 6 outgoing connections. And then lastly, we see the full timeline of the attack. So you can see everything related to this malop or malicious operation from start to finish plotted along this attack timeline. And this is a really unique feature that only Cybereason offers. The reason that we're able to put this timeline together is because on our back end, that engine that's doing the behavioral analysis, we're constantly plotting data points against each other. It's actually an in-memory graph database that we use in order to conduct this behavioral analysis. So as we're getting new information in, we're constantly updating all of the different data points and connecting all and relating all of that information, so that once we've understood that this is actually a true malicious operation, we can pull together all of those related data elements and give them to you in this clean and easy to understand timeline. So the other really cool thing to point out here with PowerShell specifically is the command line. So once you have gotten this malop, this alert that there is a PowerShell malicious use of PowerShell in your organization, we can actually see the full decoded command line. And so what we can see in this is that the attacker was actually trying to run invoke expression from base 64 string. And that's an abnormal use of PowerShell. So we know from this case that the attacker is attempting to do something malicious within PowerShell. It's a malicious behavior of PowerShell. It's not a legitimate use of the tool. So it's something that we want to go ahead and stop. And what we can deem from the timeline here is that most likely the attacker was conducting PowerShell in order to expand their footprint and gain, basically conduct lateral movement, because what we can see is that he's going from reaching multiple machines. So as we said, it had affected 4 different machines, so we can see that in order to gain access to the CEO's machine, the attacker is using lateral movement in order to, or using PowerShell in order to conduct lateral movement. Cool. All right, so in addition to detection, that's really what I talked about in the demo, we are also very, very excited to announce that we can also block malicious use of PowerShell. So this is something very unique. We are first to market with this capability. And what we're doing is actually proactively stopping these malicious PowerShell attacks. The way that we're able to do that is because we provide full visibility into the activities and commands taking place within the PowerShell scripting engine. So with this visibility, Cybereason is able to decipher that normal activity or normal behavior from the malicious behavior by detecting patterns of activity that indicate malicious behavior. So for example, when attackers use PowerShell for malicious activities like credential theft, there are certain patterns of behavior that we can identify within the scripting engine that tips us off to this. So that's in addition to the command and control communications and privilege escalation. And when the solution does detect those malicious commands, it proactively and automatically blocks those malicious TTPs from running. So this is a very unique feature. It's not just detecting the malicious use, it's actually blocking it up front to stop the attacker from executing this whatsoever. So, and many vendors out there are trying to build some capabilities around this, and so far nobody has actually succeeded. So it's a very exciting feature that we are just announcing today. So with that, I'll pass it back to Holger to see if we've gotten any questions from the audience.
Excellent. Thank you, Jessica. All right, let's see. The first question, Jessica, is can Cybereason detect PowerShell scripts that are obfuscated? Jessica?
Yes, yeah. So obfuscation is really noisy, and it really gives us 2 chances to identify. So first, we identify obfuscation techniques using machine learning, and second, we're able to de-obfuscate most techniques and determine if that original command is malicious. And you can see that in the demo, where we are able to actually de-obfuscate the command line.
Excellent. The next question is, beyond PowerShell, what else is Cybereason doing to protect against other types of fileless malware?
Yeah, so I mentioned that there's multiple types of fileless malware attacks. PowerShell is certainly the most prevalent and the one that we hear the most about. But Cybereason is able to detect all different types of fileless malware attacks. So PowerShell, we can detect WMI, WScript, VBS. From a detection perspective, we can detect all of those today. When we talk about proactive prevention, that's where today we're just at a point where we can prevent PowerShell attacks. We initially started with PowerShell because of its prevalence, because it's a top concern for our customers, and it's a natural place to really begin the process of being able to prevent fileless malware attacks. So that's where we started. We're certainly looking to expand that capability to other types of fileless malware. If anyone out there has a favorite second choice of where we should move next, we'd love to hear from you.
Excellent. Thank you, Jessica. I think we have time for one more question. And the question is, wouldn't you say that the introduction of PowerShell 5 addresses all of these security problems?
No, absolutely not, actually. So PowerShell 5, while it's the most secure and it offers the most security features, PowerShell 2 is still the most common. And as I was saying, many times an attack starts if the attacker is in a situation where they're using or they run into PowerShell 5, it'll start by just downgrading to PowerShell 2. So they can do that really easily within Metasploit, Cobalt Strike, and a number of the other tools that attackers are using out there. So even if the attacker doesn't downgrade PowerShell to PowerShell 2, it's still really easy to bypass PowerShell 5 security controls. Just like Empire by default turns off AMSI, like we were talking about. So effectively, you won't find a network that IT enforces all of the recommended logging and lockdown practices. So really, you know, what we always talk about is you need defense in depth. And ultimately, that's where with Cybereason in place, you can get that deep visibility, not only to be able to see and understand and detect when something malicious is happening within PowerShell, but with our new capability, you can also proactively be preventing. And that's something that goes way beyond just the security capabilities within PowerShell 5.
Excellent. Thank you, Jessica. It looks like we're at the finish line for today's webinar. Now, as we're closing this webinar, I would like to thank everybody in our audience for joining us, and I hope you enjoyed today's webinar. Also, many thanks again to Lital and Jessica at Cybereason for sharing your unique insights with us on how to combat fileless malware. This concludes today's webinar. I hope we will see you again at one of our future webinars. Thanks, everyone.
Thank you, Olga.